Hello everyone and welcome back to our chat app course. In this course, we are also going to implement audio and video calling with the help of WebRTC. So let's now take a look at what we are going to build. As you can see on the screen, we are going to build this kind of application in which up to 4 users will be able to join the meeting room and they will be able to communicate with the help of audio and video call. We are also going to implement group chat functionality into our application. Our application is going to have light and dark mode. We are also going to display the list of participants and you can click on any participant and do one-to-one communication with them. These are the features of this application. And as you can see, we are also going to have these controls for our application using which you can control your audio, video, you can disconnect from the call and also share your screen. Now, let's talk about the tech stack that we are going to use to build this application. We're going to need React to build the front end of our application. Along with that, we are also going to use Material UI to actually get some components for our application. And then to manage the state of our client side, we are going to make use of Redux. For our server, we are going to use Node.js along with Express. And for real-time communication, we'll be using this socket IO for signaling server and to do the stuff for audio video calling and to create data channels for our messages, we'll be using WebRTC. Let's talk about what are the prerequisites for this code. If you have just a beginner level knowledge of JavaScript, okay, or some familiarity with one stack, then you are good to go. But don't worry if you don't know much about development yet, because in this course, I have explained everything from scratch. So even if you are a beginner, you just need to take a look at the last two modules, which are dedicated to Material UI and Redux. Okay, so I have explained everything that you need to know about all the technologies during all the modules that I have taught in this course. Now, these are some of the features of this course that you should take a look at. In this course, we have total 12 modules. We are also providing doubt assistance. You are going to get quizzes and assignment during all the modules. You can have lifetime validity. And last but not least, you can also have one-to-one mentor interaction if you participate in this course. Okay, and along with this course, we are actually giving you 30-day money back guarantee to make sure that you are fully satisfied with the course. So if you are not satisfied with the course, you can ask for your money back, and rest assured, there is no question asked, 30 days money back guarantee. And after the completion of this course, you are also going to get certificate. Okay. And let's also talk about myself. I am Shreyansa. I am an experienced software developer based out of India. And from the last year, I have taught many students. Okay. So that's about me. These are the modules of this course. Okay. As you can see, these are 12 different modules that you're going to get along with this course. Now we have these first 5 modules on YouTube. Okay. And to access the last 7, you are going to need to have this course. We are going to run early bird offer for 1 week. Okay, you're going to get extra 30% off in this early bird offer. Along with that, you will also get access to a free socket.io course, and this is a limited time offer, so you need to hurry up. And let me show you how you can visit our website and register into this course. So you just need to open up your browser, okay, and visit learn.codingmonk.in. Okay, so when you visit our website learn.codingmonk.in, I'll also provide the link in description. Okay, then you just need to click on this courses button and click on this first recommended course, full stack chat application with advanced features using one stack. Okay, and here you can see we are running this early bird offer using which you can get 30% off. Okay, and this course is going to have these 13 modules. You are going to get lifetime access and certificate of completion. You can also see what are the different modules, and you can also explore the content of these modules. Okay, and we have also provided you the preview, okay, that you are currently watching on YouTube. So that's it for the introduction. Let's now get started with our first module, which is the intro module. In this module, we are going to learn all of the concepts that are going to be needed during this course. Okay, the WebRTC concept. This is a theory module, so I am going to recommend you to please make sure that you do not escape this, okay, because these concepts are very important. Let's now start with our first module. So let's understand what is mesh architecture that we are going to implement with the help of WebRTC. In our application, the first thing we need is if two users want to connect with each other, then they should be able to exchange audio, video, and data between them. And that is exactly what WebRTC is going to allow us to do. So as you can see here, WebRTC, if you understand it in simplest terms, it is going to allow us to have direct connection between two users. And when that direct connection is established, we will be able to send, or you can say exchange audio, video, and other kinds of data between these two users. Now, let's come to the topic of group call, because that is exactly what we want to implement in our application. And what happens in a group call? Let's say we have a room. Okay. By room, you can just imagine like a physical room. Okay. And if one user comes into that room, then we add another, then we add another. Okay. And this, in this manner, we keep adding users. Okay. To that room. Then this will be a multi-party call. Okay. So we call it multi-party call. When there is a multi-party call, then there will be slight complexity. So here I have written that the rules of the game are going to change. That means it's going to be a little complex, but don't worry. I'm going to explain everything to you in very simplest terms. So let's see what are the different strategies that we have in place for group call. So there are these famous strategies that we can use for implementing group call in our application. The first one is called mesh. Okay. And by mesh, we mean multiple direct connections. That means each user is going to be connected to every other user in the room directly. Then we have multi-point control units called MCU in short. Okay, this is a bit more advanced strategy. Okay, and then we have even advanced strategy called SFU, which is selective forwarding units. So these two, MCU and SFU, are used when we want to create an application for larger number of audience. But in our case, we're going to just implement mesh. Okay, because I'm just going to explain you how you can create an application which can handle up to 10 or 20 persons in a room. Okay, that is the focus of this course. Let's visualize it. Okay, so as you can see, we have, let's say, 3 users. There's 1, 2, and 3. And then what happens in a mesh architecture? You can see this user 1 is connected directly to user 2 and user 3. And same is the case for the other 2 users. And that is what I have written over here, that in mesh architecture, there are multiple direct connections between every user. Okay, and these, we are assuming that they are all in the same room. Okay, because whenever the communication is going to happen, they will be joined in a common group, or you can say common room. Then let's see what happens if there are 4 users. Then you can see the number of multiple direct connections that just increased. Okay, earlier each user was having 2 direct multiple connections, but now each user is having 3 multiple direct connections. So you can now imagine what happens in a mesh architecture. As the number of users grows, the number of multiple direct connection is also going to grow. And that is why this is going to be very CPU intensive. Okay, and this is not a very scalable solution, but it's a better if you learn mesh architecture in the beginning, and then you can learn about the other 2 architecture, MCU and SFU. Now let's discuss what are the limitations of mesh architecture. Since we are learning mesh architecture, we should know both pros and cons of this architecture. So as I just explained you, when the number of users is going to increase, then it is going to be very CPU intensive. That means it is going to consume so much bandwidth that at one point our computer or our mobile device is going to break. Okay, it won't be able to handle that kind of processing anymore. So that is why this is not very scalable solution. Okay, and the same thing is mentioned here in the second point, that you can actually run this quite easily on your desktop device if it has a higher processing power, but the problem is going to be more visible on low end spec devices. Okay, like mobile. Okay, where resources are much more limited. Then let's also discuss these other limitations. Okay, so as I just explained, mesh is actually the easiest way to implement multi-party call, and because all the work is done in your browser, we don't have to manage any server in between. Okay, but the problem is it is only going to work for a small number of users. Okay, So if you want to develop an application which can handle, let's say, 20 or more users in a group, okay, then it's better if you go with some other architecture, okay, that I mentioned in the previous slide. So the same is explained over here with an example that in a group of 5 users, each browser is going to have 4 direct connections, okay, for sending and receiving streams from other peers. And by peers, you can just imagine peer is the your colleague, okay, in the same room that you are communicating with. So that's it for the mesh architecture. I hope I explained it to you. If you have any doubts, you can ask, okay, in the community. So in the next video, we are going to learn more about how to implement WebRTC in our application. In the last video, we discussed about mesh architecture that we are going to use in our application. Now let's understand in detail how WebRTC is actually going to work. So here I have created a visual diagram for you. Okay. So let's assume that we have 2 callers in a room, or you can say 2 persons. You can call them peer. Okay. Now this is our caller, okay, which is going to make a call to the callee. So we are calling this right side callee and the left side caller. So the first step is to send a request, okay, and that is made through a signaling server. You can see here at the top, this is called signaling server. And when this caller wants to make a call to the callee, first it's going to emit an event, okay, that will be received by signaling server. Then the signaling server is going to emit an event to callee asking that this user wants to connect with you, okay. And if callee is available, okay, then that information will be sent back to the caller again through signaling server. Now when the 2 users are ready to connect with each other, then they need to share some information about their browser and their internet connection in order to be able to establish a direct connection, okay. So when that audio video call is going to happen, there will be a direct connection, but right now they are just confirming if the other user is available. When that is confirmed, what is the next step? Then the next step is that both the users are going to fetch their IP address information, okay, or their internet connectivity information, or information about their browser, and all of this information is going to come from another server which is called stun server. Here you can see both caller and callee are going to request that data from their stun server, okay, and stun servers are public servers that we are going to actually implement in our application, okay. So after that information is fetched, that information will be again shared with each other or exchanged via signaling server, okay. And after a lot of negotiation happens, okay, like the method in which these users are going to connect, I'll explain that to you in the next videos. So when that is done, then there is a direct peer-to-peer connection, okay. Then that means signaling server is not going to help us in exchanging the audio, video, or the other kind of data that we want to exchange. That will be done through a direct peer connection that called WebRTC peer connection. So now you know that this is not a one-step process. First of all, there is a signaling server involved in between, okay. Then there is also a stun server, okay. And let's now understand what is this stun server, okay. So what happens, sometimes these 2 users won't be able to connect directly, okay. That means there are some limitation due to, you can say, their internet connectivity or their browser, due to which a direct peer-to-peer connection won't be possible. So in that case, we create this turn server, okay. Turn servers are actually private, and we are also going to implement one in our application. So we connect to the turn server and the data will be exchanged through a turn server. This is going to act as a intermediate application, okay, which is going to actually receive audio and video media streams, and that will be exchanged through this turn server. So this is in a nutshell how the audio video call and the chat is going to happen in our app. Now let's summarize what is WebRTC. First thing you need to remember is that it's an open source project, okay. And what it does, it enables peer-to-peer communication, and it enables exchange of any kind of media. It can be audio, video, or it can be, you can say, any kind of image or any kind of message, okay. So WebRTC is going to enable us to do all those kind of things. And the most important part is it doesn't require any plugin or framework. It's an API built into web browsers. Okay. Now, it's also good to know which companies or which applications are using WebRTCs. So there are lots of companies, but the famous ones I'm going to mention it over here. Google Meet and Hangout. I'm sure most of you have used this. So they use WebRTC to implement functionality in their application. Similarly, Discord and Facebook Messenger are also using WebRTC for their audio video communication. In the last video, we talked about signaling server. Let's now understand in detail how this signaling server is actually going to work in our application. So here we have two users, user A and user B. They want to communicate with each other, and let's now understand step by step what is going to happen exactly. First of all, user A is going to send a request to user B that he wants to connect, but it cannot happen directly because they are not yet connected. Okay, there is no direct connection between them, but there is one thing common between them. Both of them are going to be connected to a signaling server. Okay, so when this user A wants to call user B, then he is going to emit an event to the signaling server. Then the signaling server is going to tell user B that user A would like to call you. And if this user is available at that moment, then an event will be sent back. Okay. Then in this way, the user B is going to tell user A that he is available to connect over call. Okay. And that's when they're going to fetch their SDP information and ICE candidate. And what is this SDP info and ICE candidate? This is actually the networking information and information about their browser that they're going to get from the instance server. Okay. So there will be one more step, but I have not shown that over here. But they are going to get this information called SDP info and ICE candidate from instance server. Then they will be exchanging that again through this signaling server. Okay. So this is how they are going to exchange that information again. And after negotiation, okay, these two browsers, their browsers are going to confirm that now they are ready to connect. Okay. And that's when user A and user B are going to be connected directly. And that is what we call live direct peer-to-peer connection, in which they will be able to share audio and video stream. Okay. And our audio video call will be happening there. So this is how the signaling server is going to act inside of our application. This is the purpose of signaling server, I hope. So this is the importance of signaling server inside our application. Let's now discuss what is instance server in the next video. Let's now understand what is instance server. So as we saw in the last video, when these two users want to connect with each other, in the second step, they were exchanging some kind of information about their browser or their internet connection. Okay. And we called it SDP information and ICE candidates. Now to exchange this information, first they need to have it. And for that, they are going to utilize something called instance server. Okay. So when these two users are going to connect with each other, they will be first of all fetching the information that they need to exchange, okay, from the instance server. And that is transferred between these two users using this signaling server that we understood in the last video. So let's now summarize this. You can see instance server is going to help us to determine the public IP address of our computer, and also it's going to help us to assess the network conditions. And based on that, it is going to tell us what are the different ways in which the two browsers can join with each other. Okay, and this is a very important step in WebRTC connection, and it becomes even more important when the two computers that we are going to connect with are using some kind of firewall or they are behind some net. And you can see, as I have written over here, the information that is obtained from the instance server and exchange between the two users, that will be used to optimize the direct communication setup between devices. And what I mean by this, that there can be multiple ways to connect. Okay, so this instance server is going to tell us all the possible ways in which the two devices can communicate with each other. And then when both the browsers share their information with each other, then they are going to agree upon one method. Okay, and that will be the most optimized manner in which they will be connecting. So that is what is the importance of Stun server inside our application. Let's now finally talk about what is this SDP that we are talking about again. So as you can see, this SDP stands for Session Description Protocol. Okay, that is, you can actually derive what this means, okay, by its full form. And by definition, when let's say we have two devices and they want to connect with each other over WebRTC, okay, that will be a real-time communication. But in order for that to happen, they first of all need to know in what way they are going to connect, okay. And for that, they need to exchange the information about the session. And this is where this SDP comes into play, okay. This is going to help us know in what manner these two computers are going to communicate with each other or connect with each other. Let's understand this in more detail. So what is going to happen? We have something called an offer answer model. That means when these two computers want to connect with each other, the first computer is going to offer this one some information, okay, like I can connect over this IP address or this port, okay, in this particular, using this particular protocol. Then this computer is going to give this one its offer that I have this much capability, that I have this particular method of connecting with you. And when there is something that these two computers are going to agree on, okay, that is when the connection will form and a live direct peer-to-peer connection will be established. Okay, so that is why it's important to share this SDP information. And the model that is going to work over here, that is called offer and answer model. And when this offer is shared, this information is actually transferred between the two devices. First one is media type, like audio, video, or data. What type of data is it going to give the other one? The codec information, which is going to specify the encoding and decoding algorithm, okay, that it is going to send the data in. Also, it's going to send the network information like its address, ports, and protocol that it's going to use for the communication. And the last thing that it's going to send is session description, information about the overall session that it will be able to create. Let's now visualize this. So here we have two devices which are going to connect with each other. Okay, and here we have an offer and an answer. So in this offer, you can see there is lots of information. Here in the answer, there is also some similar information, and the contents are similar to what I just explained you in the previous video. Here you can see these two are going to agree that they can connect over PCMU. This is some kind of protocol, and they want to connect over 8000 frequency. Okay, and the data that they are going to exchange over here is going to be audio. So this is how these two computers are going to communicate with each other, okay, over what port, what address they are going to connect, and in what manner. So this is how this SDP information is going to serve its purpose inside our application. So you can basically summarize this using these two definitions, that what happens is devices may go through multiple rounds of offer and answer. That means they're going to share multiple different ways of connecting with each other until they agree on a set of parameters for the communication session. Okay, so if they agree for a particular set of, you can say, method of connection, then the connection will be established. And once both devices agree, okay, use over the session parameters that they are sending each other, okay, then they are going to use that information to set up their communication. Okay, and that is when the direct communication is established, and then both the computers will be able to share audio, video, or any other kind of media directly with each other. So that is SDP in a nutshell. Okay, let's now discuss what is turn server in the next video. So let's now understand what is turn server. So this diagram is actually very familiar to us. We discussed it earlier as well. The only difference is that we didn't discuss this turn server thing in between. Okay, so here you can see there are two users, user A and B. They want to communicate with each other, and for that they're going to need SDP information, for which they can utilize turn server, okay, which are public servers, and it's hosted by companies like Google and others. So after that, SDP information is received by both the users and exchanged through signaling server, okay, then we are expecting a direct peer-to-peer communication, but that is not the case always. So what happens, In some cases, the direct peer-to-peer communication is just not possible. That means it can be due to various reasons, okay? That the users are behind some kind of firewall, okay? Or they have asymmetric nets. But what is going to happen? We can still connect, okay? That means the audio and video call will still be possible, and that is going to be made possible with the help of something called turn server. And as I also told you in a previous video, that turn server is going to help us when there is no possibility of connecting directly, okay, using WebRTC. Then in that case, what is going to happen? This user A is going to send its audio or video to this turn server, and this will be relaying that to user B. And similarly, when user B wants to send something to user A, that will be happening through this turn server. And also keep in mind that this turn server is just for exchanging. Okay, it's not going to do anything with the data. So that is turn server for you. And you can just summarize it like this. Turn servers are going to relay your data. Okay, when direct peer-to-peer communication is just not possible. And they are also actually very important for these scenarios where devices are behind restrictive firewalls or asymmetric or symmetric nets. In these cases, what is going to happen? The direct peer-to-peer connection won't be possible. So we'll have to utilize turn server. And you will find in most of the cases that these turn servers are going to work in conjunction with the turn servers. Okay. And that is going to ensure a very robust, or you can say powerful WebRTC communication. Okay. So that is turn server. Now in the next video, we are going to discuss the last thing, that is called ICE candidates. We must understand what is ICE candidate in detail, okay, in order to understand WebRTC in depth. So let's understand that in the next video. And you're going to hear this term a lot in our next videos. So let's now understand what is ICE. By ICE, we mean interactive connectivity establishment. Okay. And in simplest terms, ICE is just network address, or you can say the information about the network that a device used to send and receive data. Okay. So you can basically visualize it like some sort of a gate, okay, and the information about that gate, okay, through which the data can come in or go out. So that is ICE for you in the simplest terms. Now, what happens whenever a device is going to establish a connection with another device, okay, then it needs to have a list of all the ways in which it can communicate with the other device. Okay. And that is what we call potential ICE candidates. That means the ways in which these two devices can connect with each other. And when this list is prepared, this list is going to actually include a lot of things. It can connect over local IP address, or it can connect over public IP address, or it can even connect through a relayed address and through a turn server. So we just discussed turn server. And what happens in this third case, these two devices that we are going to connect to, they are not going to communicate directly. They are going to first of all send their information, like their media, to some third party server. Okay. And then that third party server is going to relay that information to another client that we want to connect. Okay. So let's now understand what are the different types of ICE candidates. So first one is host candidates. Host candidates means when the connection is established directly. So this represents the local IP address of the device. Then we have server reflexive candidates, and these are obtained by utilizing turn server, as you can see. And this is actually the public IP address which is seen from the outside, and this is another kind of ICE candidate. And the third one is obtained through turn server, and that we call relayed candidates. Okay. And this relayed candidate is actually the last possible way in which the devices can connect when the direct peer-to-peer communication is not possible. And let's understand by this example, okay, what are this ICE candidate in detail. So each ICE candidate, as you can see, will be in this form. Okay. It is going to contain certain information. Okay. And let me explain you piece by piece what this is going to convey to us. The first thing that you need to pay attention to is this host. This host means it's a local address that the device is like requesting the other device to connect over. Okay. And it has this priority value at the start, and each ICE candidate that is sent to the other device has a priority value. And this indicates like which method we should use first to communicate. Okay, so that is why these ice candidates are going to have a certain priority value. Okay, then there is also this specific protocol that it's going to use, that is UDP. Okay, and it is also telling the other device that it wants to connect over this 49172 port. Okay, so that is what we have inside this each ICE candidate. Okay, this kind of information is sent between each browser that wants to connect. And what happens, there is a negotiation process in between. As you can see here, these devices are going to share multiple ICE candidates with each other, and they will be verifying if they can connect over that method or not. Okay, until they agree on the most suitable one. So when that happens, when the negotiation is complete, these devices are going to use the ICE candidate that they have finalized, that they are going to connect over this. Okay, and then they will be attempting direct peer-to-peer connection again. And in case direct peer-to-peer connection is not possible, then they will be going for turn server. Okay, that means the audio and video will be relayed through a third-party server. So that's it. Now we have completed all the theoretical concept that we needed to create this application. If you want these slides, you can download it. Okay, I'll be attaching that in the same module. After this, we are going to actually set up our environment for development. So let's move on to that. To create our application, we are going to need to install Node.js on our system. So for that, you can open up your browser, okay, and search for Node.js on your Chrome. Now you need to click on this link, nodejs.org, and from here you can see this is the current long-term support version 20. So you can install it. Okay, and by the time you are watching this video, it may have been upgraded. So you need to install the latest version. Okay, so just click on this LTS version and a file will be downloaded. Okay, and that will be according to your operating system. Now you just need to open up this file and click on next. Okay, and give it all the permission that it needs. And after the installation is done, okay, how you can check it, let me tell you. You can just open up your terminal, whether you are working on a Windows machine, Linux or Mac OS. You can just open up your terminal and write node dash dash version. Okay, and press enter. Here you can see I have version 16.16 installed on my computer, and similarly you can check if npm is installed in your computer by writing npm dash dash version. So here you can see version 8.11 is installed for npm in my system. So that's it for this video. In the next one, we are going to create our server, and we'll start by installing some dependencies and setting up our server. So now if you are able to see the node version and npm version, then we are good to go, and now we can proceed and create our application. So the first step for doing that is you need to create a new folder, and I am here on my desktop and I'm creating a new folder. Let's call it WebRTC Advanced App. Okay, so I'm calling my app WebRTC Advanced App. Now what we need to do, we need to open this on terminal. So here I am inside my terminal. Then I'll navigate to desktop. Okay, then here I am going to again navigate inside my application that I just created, WebRTC Advanced App. If you see, this folder is currently empty. Okay, but we need to create two things inside it. The first one will be our server repository, and the second one will be our client side repository. Okay, so let's create the server side repository first of all. For that, you can just again go inside this folder and create a new folder. So click on this new folder, and I'm going to call it server. Okay, and for the client side, we don't need to create a folder because we'll be using Vite.js to scaffold our application. So that will take care of creating the folder for us. So let's now go back inside our terminal and cd into server folder that we just created. Now inside this, we need to first of all do npm init. Okay, so that we can install dependencies and start working with our server. So first of all, you need to write this command when you are inside your server directory, okay, in your terminal. Then after you type this command npm init, you will be prompted. Okay, as you can see, it is asking me the package name. Here I'm going to leave it as server version 100. That will be fine for me. Let's leave the description as empty. Entry point, I'm going to change this one to server.js. Okay, I'm going to leave test command as empty, git repository as empty. I'm not going to provide any keywords. Author, you can fill in your name. I'm going to write my name Shreyas. Okay. License, let's keep it ISC. And now it's asking if this is okay. Just write this yes and press enter. Okay. Now we have done npm init. You can now write code dot. Okay. And this is going to open up your repository in your VS Code. Okay. Or whatever IDE that you have configured. So now we have our package.json file. Okay. The next step is to install some dependencies. So here I am again inside my terminal. And to install dependencies, first of all, you need to write this npm install. And whenever you are going to send a zip file of this project to someone, or if you are giving this code to someone, then they just need to install the dependencies and they will be able to run your code. So here we are going to get some packages. Okay. And we'll provide this option dash shape so that these modules that we are installing are saved as dependencies. So the first module that we need is course. Okay. Then this module is actually going to be used to be able to communicate cross origin. Okay. To make cross origin requests. So that is why we need course. After that, we obviously need Express because we are going to create a Express Node.js server. Then for creating our signaling server, we are going to need socket.io. Okay. And to create the turn server, we are going to be using Twilio. So for that purpose, we are installing this package. And to create random user IDs or IDs for our room, we are going to use this package called UUID. Okay. So that's it for this video. Now you just need to hit enter and these dependencies will be installed. Now in the next video, we'll set up our server. Okay. And we'll start working inside it. So now as you can see, we have successfully installed our packages. Okay. And if you go back inside your IDE, then you can see now we have these dependencies block inside our package.json file. And since we installed these modules, we have this extra folder called node modules. But remember that if you are sharing this code with someone else, then you don't need to share this node modules folder because it contains a lot of files. Okay. So we'll never share that. Okay. The other person just need to run npm install and all of these packages will be installed for that person as well. Now the next step is to create a new file over here and we are going to call it server.js. This will be our entry file as we mentioned inside this package.json. Here you can see our main is server.js. Okay. So let's first start by importing the modules that we installed. Okay. So first thing that I need here is Express module. Okay. So I'm going to just require it like this. And in the similar way, we are going to import our other packages. The second one that we need is HTTP because we are going to create an HTTP server. But if you remember, we haven't installed any such package. And that is because HTTP comes in with Node. Okay. So we don't need to install it separately. Okay. And then we are going to need this UUID. Okay. So we can install the version 4 of it like this. v4 as UUID. Okay. Require UUID. So this is how we can get this package. Okay. And we will be using it to create unique IDs for our users and also for our rooms. And after that, we are also going to need this course package. This course package, as you already know, okay, this I told you this will be used so that we can connect from different ports and different IP addresses. Okay. So, or you can say in simple words, we are going to allow cross origin requests on our server. So that is why we are requiring this package. Then the next package that we will need later on is Twilio. So this will be used to create turn server. Okay. So that is why we are requiring it over here. Twilio from Twilio like this. Now the next step is to create our server. Okay. Or to create the application using Express. But before that, we are going to define on which port our application will be run. So let's create this constant over here. Okay. And I'll define it like this process.env.port. And currently we are not going to define any environment variable, but that will be done when we deploy this application, okay, into production environment. But in our case, currently in development environment, I will be using this fallback 3000 port, okay, to run my application. Then we can create a simple application using Express, okay, like this. You just need to call Express, and your application will be created. But to create a server, okay, and listen for in to respond to HTTP request, we need to create a HTTP server. So that can be done simply like this. You just need to call HTTP and then call this create server method on it and pass this Express application that we just created. And to allow cross origin request, you can use this middleware course, okay. That can be done like this, app.use, and just pass course inside it and call course, okay. Then the next step is to create our socket IO server, okay. And for that, we can do it simply like this, const IO is equal to require, and here we will be requiring socket.io, okay. And after requiring it, we can just call it directly and pass the HTTP server that we just created. And after this, we can pass some configuration over here. And the one configuration that we need over here is course. Okay? We need to configure course for socket IO as well, because we will be connecting through different ports and IP addresses. So I want cross origin request to be made to our server. That is why we are defining it. Since we are not restricting it, okay, so I'm going to enter this asterisk. This means that all origins are allowed, okay. No origin will be blocked. Then we also need to define what methods will be allowed. So the first method that I'm allowing is get, the second one will be post. So these are the request methods, okay. And if you don't know about this, these are like, there are different kinds of methods which are defined for making API calls. Get is for getting data, post is for creating some data onto our server, okay. Then as a final step, we need to just listen to our server, okay, onto some port. So we can just write it like this, server.listen, okay, and the port will be derived from this constant port. And after our server starts listening, okay, a callback will be fired. So in this callback, we can log something onto our console. So here I'm going to write console.log, and let's write this server is listening on, and here I'm going to use variable port like this, okay. So that's it for our server configuration. Now we have a very basic server configured for us, and we can actually start running it. So you can just open up your terminal and make sure your current path is on server. Then you can just write node and then the name of the entry file, that is server.js, okay. So if you write this, you can see now here we have a error, and that is because I misspelled course to cross. So let's see, this is on server.js. Let me find it out. So here I have a spelling mistake. This is course like this. Let's save it again, and I'll be running my application one more time. So now you can see we got this message, server is listening on port 3000. So this means that our application is now running successfully. And one more thing that you should notice over here is that I can use Nodemo to run my application, so that whenever something is changed, okay, whenever I save a change in my files, then the server will be restarted. But I'm not doing that over here because I want to manually restart my server whenever I add some socket event, okay. I will be emitting various events and also receiving it on the signaling server. So we'll be doing a lot of things inside this file, like managing the number of users, number of rooms, and exchanging all the HTTP data that we talked about in the previous module. That will be done over here. So I hope everything is clear till this point, okay. So in the next video, we are going to create our client application using WebRTC. So now it's time to create our client-side application. And for that, I'm going to use this WebRTC.dev to scaffold my React application. As you can see, WebRTC is a next generation front-end tooling platform. Okay. Now, in order to get started, just click on this blue button that you can see over here. Okay. And this will take you to the page/guide. And here you need to just scroll down a little bit. Okay. And you will find this command for scaffolding your first white project. Here I'm using npm. Okay. So I'll copy this command from here. Then just open up your terminal window. But here we are going to make sure that we are inside our WebRTC advanced app, not inside server. Okay. So I'm going to take a step back using this cd // Now I am inside WebRTC advanced tab. Then I can just paste the command, okay, that we just copied, then press enter. Now, when you do this, you are going to get some prompt. Let's wait for it. Okay, so now it's asking the project name. Here, I'm just going to give my project name client. Okay, then press enter, and you will be prompted to choose the framework that you want to use. Here, we will be using React. Okay, and to create this application, we'll be using JavaScript. Okay, now our application is scaffolded. Then you can see here we got this message done. Now you can run these commands in sequence. Okay, so let's run them one by one. Any client. Okay, that's the first step. Then we need to install the dependencies. Okay, so write npm install and hit enter. Now let's just wait for a few seconds until these dependencies are installed. Okay, so now as you can see, we have successfully installed all of the packages that we needed. Then next thing we can do is to open this code in our code editor. For that, I'm writing code space and then dot. This is going to open up my code base inside VS Code. So as you can see, this is our client repository. Okay, and the first thing that we need to do over here is to remove some pre-written code. Okay, so first thing that I'll do is I'll delete this app.css file. Okay, so let me delete this app.css. Then I'm also going to delete index.css file. Okay, now inside app.jsx, okay, I'll be removing all of this JSX that is written already. We are just going to leave this React fragment, this angle bracket syntax. This is called React fragment. Okay, and let's also remove this counter state from our application, and we are not going to use any of these import statements, so I'm also going to remove them. Okay, then after this, let's go inside main.jsx, and here this index.css import is not needed anymore, so we can just safely remove that. Okay, so that's it for this, and now we can actually start our application. And for that, you just need to open up your terminal and make sure that you are inside your client repository at this point. Okay, then just run this command npm run dev. Okay, and when you run this, let's see, now our application is running and we can access it on localhost 5173. So let's see how this is looking. If I just go to localhost 5173, for now it's going to be just an empty page. Okay, and just make sure there are no errors in your application when you run this command. So now we are good to go. Okay, we have scaffolded our React application. In the next module, we'll start building the client side of our application. And for that, we are actually going to use two things. First one is Material UI. Let me tell you what is Material UI. Material UI is a React component library, and you can visit the site over mui.com. Okay, so we'll be using this to create components inside our application, and to manage the state of our application, we will be using Redux. Okay, so both of these things will be taught in the next module.